Hey guys, we're going to have a showdown between the ET13S, the ET14S and this, which I'll just show you because I didn't make a specific review of this thermal camera multimeter, but this comes in the same sort of holder as the ET14S, basically the same package with the leads, USB, spare fuse, a multimeter, okay, and here it is by the magic of video editing, the ET15S. I'm going to concentrate on the thermal cameras on this video. I'm just going to try a couple features of the multimeters, these ones, because people have been asking for. So when I made the previous review, I offered to show people on the next live stream anything else they would like to see, but one voice is shouting quite loudly, so I'm just going to test the current range. Also, I noticed that this multimeter behaves rather strangely if we connect a diode in continuity mode. I know you're supposed to put diodes in diode mode, but most meters won't behave crazy. Yeah, and this thing did. I'll just show you that as well. I want to see if this does the same, and we'll actually try it on this one as well. Okay, so let's get these few things out of the way first, and then we will get onto the thermal camera. So, measuring current. This is interesting actually because this multimeter, the ET13S, does not have any current range. It has two terminals, these have three, so this cannot measure current. Let's see how the other ones do. So here I have a 160 ohm resistor, 10% tolerance, it's not a close tolerance. I've connected this to the positive end of my bench power supply. I've set it to 5 volts at the moment. So we will connect into the input, okay. And then I'm going to connect another lead from the common back to my power supply. And here we have it. Common to my power supply, okay. We'll see the current on the power supply, and of course we should switch the multimeter on as well. And we should select current. Okay, amps. So what does it do? Well, it's passing not much current. I mean, we could work this out by Ohm's law, but this is telling me it's 30 milliamps. This only has 2 digits. That's telling me it's 32 milliamps. Okay, let's try this one as well. This is showing me a nice little menu. It asks me for the language. I'll just show you this while we're here. Just explaining here what the various buttons do. Okay. Multimeter mode. Thermal imaging mode. Okay. Built-in user manual. How about that? And we have a completely different display on this one. Looks very different actually. Non-contact voltage. Let's try the amps. See the things rotating around. Continuity. Ohms. Amps. Okay, so we're on the amps range. Let's see what this one reads. This one's gone to sleep. Okay, so let's just see. The same, okay, give it a bit more voltage, so a bit more current. That's as close as I can adjust it to 100 milliamps, okay. This one, yeah, so this actually has an extra digit of resolution, we notice, but they both work fine measuring current, okay. The other thing I would like to test is how these meters all behave in continuity mode and in diode mode. So let's select continuity mode on each multimeter, and we do it differently. So this one, we press the little button on the side, up or down, and it moves to the next icon, and we sequence through them like that. Okay, this one, similar thing, the button on the side, but this gives us like a little wheel thing here. Can you see it? With various icons, so we can amps, ohms, capacitor, continuity. Okay, and this one doesn't have the button on the side, and this one actually has a touch screen, which means you can switch easier or quicker between the various ranges. Actually, I think I prefer that than the way the other ones work. So there's no touch screen on these. Okay, so I'd say that is a definite advantage of this one. Now then, in continuity, yeah, continuous bleep. Okay, we'll take a 1N4007 silicon diode, and it does this thing flicking. Now it's stopped. Let's do it again. So it's kind of like, I think it's making the diode conduct and not conduct. Let's see what happens with the Schottky diode. Same thing. Okay, just as a comparison, and this is what I'm looking for on my Fluke or my ZYIE. If I go to continuity, continuous bleep in the ohms range. Okay, if I take a diode, it doesn't do anything. Okay, and the ZYIE is the same. So these meters have this rather strange behavior there. You probably wouldn't notice because you don't generally test diodes in this range, but that's what's happening. Okay, let's try these ones. So again, does it remember the last range it was on? Yes. So continuity. Let's try it. Continuous bleep. And it's fast. The other one was also fast. Diode. Doing that same thing. Schottky diode. Doing that strange thing. And the 15S. Ah! I've just done the same thing I did on the other one, by the way, in amps range. Look, leads connected incorrectly, yeah? We'll try that on this one in a moment. I did that accidentally. Okay, so to there. It's now changed to ohms. So this is actually detecting the lead. Continuous. Yep, fast. Diode, what does it do? This does not do that weird behavior, okay? So only this one does it. Yeah, nothing. So this acts strangely, you can see that, okay? Yeah, goes to amps. What's this one do? Ohms range. Says ohms, go to amps, doesn't. So this one detects the leads, this one doesn't, okay? And this one doesn't have the amps range. Now let's try this one in diode mode. So again, short, continuous bleep. Not exactly fast, but it does do it. And with the 1N4007 silicon rectifier, one blip. Okay, 0.58, and with the Schottky diode, one blip. So again, this does pass the Mr. Bleep test. It's not the fastest, but it does work. Okay, the ET13S in diode mode. Again, just touch the screen on this one. Okay, so continuous bleep, but it's not fast. One blip. And the Schottky, one blip on the normal diode, silicon diode. And this one, well, this has a continuity. Do we then have to press something like select to go to diode mode? Yes. Okay, so a little bit more finicky to use than that one in particular. Okay, so continuous bleep. Not particularly fast. Diode. Blip. Blip. Okay. So they all pass the Mr. Bleep test. You can see they all operate in quite different ways. I'll just again show my Fluker's comparison because this is what I use when I'm fault finding for this reason. If we go onto the diode range, faster, yeah, faster. Blip. Blip. Okay. I won't go through all the other tests on these on this video, but we have a live stream every second Sunday. So if you would like to see any of the other multimeter functions tested on any of these, let me know in the comments. We will do that on the live stream. If you can't watch live, no problem, because all the live streams are available for viewing later once they end. And if you're on the live stream, you can ask directly there. So we will look at these multimeters again if you guys want to see anything else. But now I'm going to concentrate on what I'm sure most of you want to know, is how well the thermal cameras work on these three multimeter thermal cameras. Firstly, we'll look at distance viewing. So I'm going to look at the air conditioning across the room. This is the 13S. Press the infrared multimeter button. Okay, takes a few seconds. We're now in infrared mode. I'm going to remove the macro lens. So this is the macro lens. On this, it's magnetic, it clips off. Okay, now let's see what we can see. It's a little bit tricky to demonstrate this for you guys. We're now looking across the room. This is the side of the shelving. Just above that, this is the air conditioner here. Okay, just trying to focus it. So we can see 25 degrees as the ambient temperature of the workshop. In green, we can see the aircon vent is 15 degrees, and the hottest place in the workshop is, let me tell you, 26 degrees. Okay, so that's the thermal camera being used to view across the room. And it's a bit blurry on the ET13S. I don't think it's ideally suited to this type of use, but it works. Let's look at the 14S doing the same thing. We can set these cameras, all of them, to boot up either into multimeter or thermal camera. So this is set to thermal camera. This is the macro lens. So on this one, it just slides. It's integrated, it slides across. So that's for the macro lens off. Let's have a look at what we can see across the room. It's similar, maybe a little bit more in focus, I would think. I'm sure you can see again, room temperature 25.8, 25.9. I mean, it is the end of January, so it's going to be a bit cooler here. 12 degrees is the lowest, and just above that, 30 degrees, 29 or 30 is the highest. I think this works better on more distant viewing. Okay, let's try the 15S. So you see the boot up screen. Loading, so this is going into thermal camera. They all take a few seconds. Okay, there we have the thermal camera. So again, I'm going to move the macro lens away. Okay, again, it's integrated, it's a slider. What does this look like? Well, I'd say that's the best of the three, to be quite honest. I can see more clearly. Try and hold it where the camera focuses. Yeah, I can definitely see the aircon more clearly there. Minimum is saying 3.3, so quite different to the others. Yeah. Average 22, maximum 27.6. This is actually reading a little bit lower. I don't actually know which is correct, but that seems to work a bit better, okay, for distant viewing. Let's have a look now at close-up PCB inspection with and without the macro lens. Okay, so the ET13S. I'm going to take the macro lens off. This is magnetic. Snaps into place. Take it off and we'll have a look at this motherboard. So, without the macro lens, I can see right under the little graticule in the middle, this is a MOSFET. I can see some small components here. I think we can see that there's something here getting hotter than the surrounding. Can you see it there? And there's also something just below the heatsink there. So without the macro lens, that works reasonably well. Okay, let's put the macro lens on. And now we see instantly a big difference. So that's those two resistors. I can see it clearly now. Before that was kind of a hot patch in front of the heatsink. Yeah, I can see 3 there. So I can see this much clearer there as the crystal. Okay, so the green graticule, that's showing the coldest place. This is showing the hottest place, and this is showing the temperature on the yellow display, exactly what I'm pointing at. Okay, and we can change the color palette and a few other settings on here, but that is the ET13S working with the macro lens, and that really is good. I mean, that's certainly good enough for repair work. Okay, let's look at the 14S. So ET14S without the macro lens. Again, I can see there's something yellow just in front of the center graticule, reticule, what you want to call it, the little pointer. I can't clearly see exactly what it is. I can see it's there. Same here, there's something there, hotter. Once again, we have the temperature of what we're pointing at, and then we have, this is the coldest and this is the hottest point it can see. Okay, but again, that works nicely enough, but we'll switch to the macro lens, which on this is just a slider. And now we can see it. So we see the 2 resistors here. We see the 3 here. I would say this is very similar to the 13S. I wouldn't say it's notably better. Okay, the screen size is basically a little bit smaller on this one. I think let's just try the 2 together if we can do this. Okay, to give some idea of what we can see. Obviously, I can't hold them both in the same place, but I would say this one possibly gives a bit more magnification, but it's a bit closer actually. They both have this timeout. I think you can adjust that actually. So that's the 2 together. And I'd honestly say there isn't enough difference between them to make any sort of purchasing decision just on that, yeah? Not a lot of difference. Okay, let's try the 15S. And once again, without the macro lens. This actually focuses a bit further away. That's probably why it was working better looking across the room. We see less detail, but it focuses further away, so we get more of an overview of what we have. Okay, I think that thing there under the center point is the crystal actually. So this doesn't work very well without the macro lens. Let's try it with it. Okay, what do we have now? Yeah, I would say this is clearer actually. It has a bigger screen too. Yeah, this one I would say gives a nicer view. We can clearly see now there are 4 resistors there, 2 here, and another one somewhere here, slightly warmer. Let's get it into shot. Okay, let's compare that with the others at the same time. This one has a bit more magnification. I'm holding them both like level with each other now, so that's the difference. Where are those resistors that we're showing? Yeah, there's two down here. And we can see them on that one. Okay, and the 13S. Again, holds at the same distance. Yeah. I would say this focus is a bit closer than this one as well. Actually, I'm having to hold this a little bit further away. Okay. So guys, we have to sum up, and I'm back in the corner of the screen. I took myself off before because I didn't want to block your view of these multimeters. I'm sure you can hear me clearly anyway. So, what do I think? Well, the thermal camera on this one was clearly better at more distant viewing. So if you're doing things like air conditioning and looking at buildings to see where there's, you know, heat leakage and that sort of thing, and that's one of your main uses, this may be a bit better for you than the others. For close-up PCB inspection, again, I think this one gave the better image, but there wasn't much in it, to be quite honest, and they're all well suited to PCB inspection. I don't believe for 1 minute you could find a fault where something's getting hot with this one that you couldn't with these two. And in fact, there really wasn't that much difference. This one was a little bit more magnification and so on and so on. So I would have to say that if it comes down to purely the thermal imaging, there isn't a lot to choose from here. The 15S clearly has the bigger screen for thermal imaging. Yeah. These two, there's very little difference here. If I can just kind of line them up at the top of the image. Yeah. This is the smallest, but there's not a great deal in it. Okay. This is the biggest. So if that matters to you, yeah, that has a bigger image. The user interface, without doubt, is better on this one. I mean, this is a touchscreen thing, you know. It's very easy to move around. This one, although it basically looks the same, does not have the touchscreen, so you have to press the side button and step between options. You can go both ways, which makes it quicker to navigate than going all the way around to get back to the previous icon, so you can actually go both ways. But it's not as nice as this, okay? This one has this little rotating wheel of legends that you have to go around. Again, you can go both ways. But you also have extra buttons you may have to press as well. Here, so for example, diode, buzzer, diode. So you have to press another button as well. So I'd say this is the, I wouldn't say necessarily more difficult to navigate, but you have to press more buttons. This is the easiest to navigate without a doubt, and that's in between. This doesn't have a current range, these two do, and this also has an extra digit of resolution as well compared to that one. Regards continuity and testing and the Mr. Bleep thing, they all work basically the same in that respect. Yeah, we have this strange thing where you look at the diode in continuity, which you shouldn't really do that, but it's not an issue. These, obviously you have the recessed macro lenses on both of these, so you can't actually scratch that. I mean, you know, you can do so, you're not going to scratch it because you can't on both of them. This one, again, you can't actually scratch the lens, but you could lose it, although it is magnetic, but you could lose it, or you may just forget where you put it rather than lose it, so misplace it. You can't do that with these, so that's something I like on these. And the other thing I really like on these two is it has the standard tripod mount, so you can put it onto a tripod or some sort of stand where you can effectively move this up and down, you know, something adjustable. You can't do that with this unless you use some sort of mobile phone holder type thing maybe, but that would probably block the screen. So they definitely have that advantage. And I think all these differences makes it very difficult to recommend one over the other, because some of those things will be more important to some of you than others will. We can have a look at the price, see if that swings it one way or the other. ET13S. Well, there are various listings, but with macro lens 144, without 133. Okay. Prices may vary depending where you live, of course. But 133,144. ET14S without macro lens, with macro lens. So with a macro lens, an extra €40. Okay. Fair enough, you have the very nice storage bag, and there are some nice features, the tripod mount and such like. So €40 difference. You have to decide, okay? And the 15S, 238 without the macro lens and 259 with the macro lens. So about 110 or so. I mean, you can see the differences. We'll stick with the macro lenses. Okay, with the macro lens, 144, 184, 259. So this is obviously the flagship of the range. So I'm going to say, you guys decide. For me, I guess you want to know what I think. This one, the best multimeter and the clearest thermal camera. This one, I would say the best value for money. And this one isn't much more than this. So if you want the tripod mount and the current range, well, it's an extra 40. Okay. I'm sure you guys, you and probably you over there as well, are going to have a lot to say about this. So get into the comments below. Let me know what you think. As my final thoughts are, if you decide to buy one of these, whichever one you decide to buy, because you feel the features or the price suit you better, I can guarantee one thing: you will not be disappointed with any of them. Okay, thanks for watching. I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.